Yeah, I guess you can see me now. All right, all right, all right. Hello, everyone. Hello, everybody. I see my team here. Wow. And now I put my Geekle t-shirt on. I have my traditional hat cap on me, and I cleaned my camera, and I believe we're all set to get started. Our Golang Global Summit 2023, which is actually the first event for Go language, for Golang community ever by Geekle. So, ladies and gentlemen, everybody from all the world, welcome, welcome, welcome. Hey, Paul. Hey, Nika. How are you people? Jump in here.
Hi, we're doing great. How is your mood? Are you excited for the conference? Because
Morning,
myself,
everyone.
I'm really excited. That's my first conference at Geekle, and I'm really looking forward to hear from our speakers today.
Morning,
Oh,
everyone.
nice.
Morning, everyone. This is I believe this is like 60th-ish conference at Geekle. so we're like Nika is on the, I guess, North Pole, and I'm on the opposite part of the hemisphere. Yeah, so uh, pretty interesting to for me personally to start new communities, because when we just started this events, it was COVID, it was lockdown, and basically everyone, they were just sitting at home and pretending they were working from home instead, like eating pizza, drinking beer, playing PlayStation, and our conferences, they were uh like just that thing that kind of brought back this whole community to normality, like when people started doing stuff again, like presenting or like learning. And yeah, and for us, it's a great opportunity to expand this community, to expand it with another great stack, another great language. And yeah, so we're excited about Go, and I guess let's go. Yeah, and
Yeah, absolutely. Thank you, Paul. I'm super excited too about new community, but uh, it has been like few years from the beginning of this project, and we keep having our mission. 3 years, 3 years, right? We keep going, keep running our mission to find the freshest best practices and use cases, pack up together in conference, and deliver to communities twice a year. So that's actually what we are about. And yeah, Nika, thank you for combining, cooking up this event. Tell us more. What to expect? How did it go and everything? Like, how did you do that?
Well, I think this event took me around 3 months to cook it, to build it all together. It was actually really nice to work and network with all the speakers. So just wanted to thank them once again for doing this. Um, for today, we will have amazing 11 speakers and amazing 11 case studies. We will have 3 blocks. After each block, we will have a Q&A session, so don't miss a chance to ask the questions you're interested in, and also just network with our speakers. That's an amazing opportunity. The first block we will have 4 speakers. Second block will have 3 speakers, and the last one will have 4 speakers as well. So I hope our audience will benefit from all the case studies, all the practical examples, and just gain some knowledge, which is why we all are here. So yeah.
Yeah, absolutely. Thank you. By the way, as always, it's our tradition ever. Like, let us know where you are. write your country, write your city, write your maybe room or I don't know, table or whatever. Where you now? Just let us know because this is what really excites our community and our team, especially because when we feel like all around the world, people from all around the world watching us and learning here, it excites us very much. I'm in United Kingdom for now, and Paul is in Kiev, as far as I know.
Yeah.
And Nico, where are you now? Let us know.
Now I'm in Ukraine as well, in Uzhhorod, which is the most western city in Ukraine. So yeah, Team
Yeah,
Ukrainians.
yeah. Actually, the project was started by Ukrainians and survived the war and keep surviving the war actually. And yeah, sometimes we work on this, agenda and speakers like from our basements because like Russian missiles are bombing our cities. But we keep going. We do not give up, and wishing you don't give up. Never, never, never. Okay, so I wanted to mention that today we actually expecting for really interesting topics like serverless, like building chat GPT client with Go. I waiting for this. I don't do Go, unfortunately, but it will be interesting for me too. Dependency. Okay, multi-threading. Well, multi-threading is a thing actually in engineering, not only for these languages. But it's all around like development, heap optimization, developing data transfer using Go, and many, many, many more. One more thing I want to tell you, guys. This September happened something incredible actually. Usually, price goes up to the conference, and the closer to conference, higher price. But now we experience this Geek September offer because we decided this is September. Well, it's a tough year for all industry, and we decided why don't we like just lower all prices for all tickets for as low as $49. So if you didn't have a chance to buy it before and it was too pricey for you, today it is a day like if you have only the free participation, go to our website, buy the ticket, and stay with us all the conference. Not only first two talks, which are actually free, and enjoy recordings and certificates and everything. And not only this event, all events we have this low price for 1 or 2 weeks. We're not decided yet, so please follow. We have architectural events, really great. We have lots of like not lots, but some JavaScript events like React, Angular, Vue. We also have very powerful event for QA engineers. So please check it out on our website.
And yeah, that actually was my part. Yeah. And I'm just kidding. Yeah, and I just wanted to let you know that I'm gonna be moderating the second and third block, and I happen to not only help with the events here and with the product, but also taking care about our enterprise clients. So if you need something, just hit me up in the chat. I'm gonna be, as I said, I'm gonna be moderating second and third block. So you can ask any questions in the chat. So if we have team leads or CTOs, or I don't know, maybe someone from the HR team, happiness people, just send me a line in the chat, and we will be happy to gather a special package for you, like for the rest of the year and maybe 2024, because as Ad mentioned, this is going to be pretty short promo, maybe 1 week, maybe 10 days. So don't miss this opportunity, because it's a Geek September. It's sort of back to school. I mean, back to studies, back to universities, back to upscaling your skills. So yeah, just shoot us a line or just send it to our email. It's info.geekle or just .geekle.us or simply pp, like double P, at geekle.us. Just shoot us a line and we'll get a super powerful package for you.
Yeah, and when we calculate it, like when you buy the team package, one event comes to you like for $5 or $6 or something like that. So
Yeah.
it makes sense to buy for 1 year per team and enjoy like super cheap price. Okay, that's enough about Geekle. It's enough about our offers. Let's move to our conference. I'm so thankful to all community members, to all program committee members, to everyone who contributed your time here, and to all community. But first, I want to read Cape Town, South Africa. I'm from Ukraine, Slava Ukraini, Heroyam Slava. Timisoara, hello. Paris, hello. Istanbul, hello. Maybe it's too early because I can't see, I don't know why, I can see lots of India and Pakistan. They usually attend a lot, but not probably done right now to us today. I'm not sure how many people on the backstage, I mean, in audience, sorry, for now, but I hope you are all ready to our content we prepared. Nika prepared for us. I'm not sure, Nika, if we have to mention anything else now, or we will just go straight to the topics.
I don't think so. I think we can just dive into this and start the conference.
Yeah, sorry for this cheesy joke, but let's go.
Let's go. I love it. Okay, yeah. Here's how it works. Like hi from Belgium. Hello. And Portugal, of course. Lots of people from Portugal. Let's go in. Yeah, let's go Golang. Let's go in. Yeah. Here is how it works. You listen to talk and write your questions in the chat. And then on Q&A session, our speakers come together and they answer your questions. We discuss it. I believe these Q&As and these panel discussions sometimes even more interesting than topics itself. So I encourage you to write questions and join our panel Q&A session. So let's get started. Our first speaker, Abhishek Gupta. He will share about building serverless application with Go. It's like I love all this serverless movement here in the world, and he works for Amazon Web Services. So we probably will hear really something interesting from this vendor, from this cloud vendor. And I don't know. He's a principal developer advocate there, so he's the right person to share technical news from Amazon Web Services with us, with community, and I'm so excited. So probably we have to start. I'm asking our technical team to help us with that. Let's do it.
And welcome to Golang Global Summit. Hi, and welcome to Golang Global Summit. I hope you have enjoyed the talk so far. My name is Abhishek Gupta, and I mainly work on Go, Serverless, as well as open source data technologies such as Redis and Kafka. Feel free to connect with me on LinkedIn and Twitter. In this session, I will talk about building serverless applications with Go. And as we go along, you will also see demos of how to implement a sample application using the concepts that you learn. But first, let's quickly address serverless as a concept. It's not a new term anymore. You can think of serverless as an operating model where you can delegate infrastructure-related concerns to another provider. the value of serverless stems from the fact that it enables developers to focus on their core tasks. And some of the key reasons are the fact that serverless technologies automatically scale up and down with demand. And since they have a pay as you go usage model, there are significant cost savings as well. Now, serverless is a broad topic, so I'm going to focus on it from two key angles. One of them, of course, is Go, and the other one is how you can build serverless solutions on Amazon Web Services or AWS. Now, when you talk about AWS, the spectrum of serverless services is wide. This includes compute, containers, databases, etc. Since time is limited, in this session, I will focus on using AWS Lambda as a compute platform for building serverless applications, along with DynamoDB as the data store and AWS CDK to define our infrastructure as code. All these have great support for the Go programming language. As I mentioned earlier, AWS Lambda is a compute service. You give it your code, which is also called a function, and the Lambda service runs and scales it automatically. Lambda's biggest superpower is the fact that it is completely event-driven. It reacts to events in your system, and you only pay when your code is running to the millisecond granularity. It supports many event sources, and you can write Lambda functions using popular programming languages, including Go, of course. Now let's take a look at what it takes to write serverless Lambda functions using Go. Go is a great fit for serverless applications and AWS Lambda to be specific. Some of the reasons include compilation to a single binary, fast startup times, and great performance. All of these factors affect the development speed, cost, and reliability of your serverless applications. The most important thing that you need to know about writing Lambda functions in Go is how to use the AWS Lambda Go library. From this library, you will mainly use the Lambda package, which is the implementation of the Lambda programming model for Go. And you will also need to use the events package, which provides type definitions for common event source integrations. And you can make use of other packages as well, but these are by far the most common ones. Now, this is a really simple example to begin with. An AWS Lambda function in Go is like any other Go code. It has a main function that points to a handler function. A Lambda function handler is the method in your function code that actually processes events. When your function is invoked, Lambda runs the handler method. Your function runs until the handler returns a response, exits, or times out. Now, this is just one example. Like I mentioned earlier, you can also use the events package. Here, you see an example of a function that responds to events from Amazon API Gateway. And notice that it accepts 2 input arguments and has 2 return types. But this is not the only signature. You can read up the documentation on the various permutations and combinations. Alright, so you have a high-level overview of what a Lambda function in Go looks like. Going forward, I will use a sample application as a reference as I dive deeper into this session. This application is a trimmed down version of bit.ly or other solutions that you may have used or encountered. I chose this since it's simple enough to explain, yet it can serve as an end-to-end example. And as you can see, the key services involved in building this application include AWS Lambda, as well as DynamoDB that serves as the backend database. Since the application functionality is exposed using APIs, we use Amazon API Gateway to securely publish these APIs to client applications using HTTP. I will not have time to dive deep into API Gateway since I will focus on how to use Go with Lambda and DynamoDB. With that, let's dive into a demo where I'll show you how to build the Lambda functions to implement some of that functionality. Now note that although the previous diagram showed 4 different endpoints or features of the application, I will demonstrate 2 features, which include how to create a shortcode for a URL and how to access the original URL using that shortcode. We start by creating a Go module and then write the function to create a shortcode. Then we create a main.go file in this new folder that we have created, and we start by writing the imports. Then we write the main function and declare a struct that represents the response from the function. And then we write the handler function. So this handler function reads the original URL from the request body and saves it to a DynamoDB table along with the corresponding shortcode. And then it returns the generated shortcode as an API gateway response object. Now let's write the function to access the original URL using the shortcode. So we'll create a new directory. And then create a main.go file just like we did earlier. And start writing our code. And we'll start off with the imports. And then we'll write the main function and declare a few constants that we're going to need later. And then we write the handler function. So in this case, the handler reads the shortcode from the HTTP path parameter. It then extracts the corresponding URL from the DynamoDB table and returns the HTTP 302, which is a status found response, along with the original URL in the location header. All right, so now we have written both the functions. Let's fetch our dependencies. For that, we will run go mod tidy. And as you notice, we have fetched the required dependencies for specifically for the Lambda packages. Now, if you notice here that this module URL shortener DB is missing, and that's perfectly fine because we haven't yet written it. All right, now let's learn about DynamoDB and how to use it with Go. DynamoDB is a serverless NoSQL database that supports both document and key value data models. Being a serverless database makes it a perfect fit for your serverless Go applications that you build with AWS Lambda. Since it's fully managed and serverless, you don't need to worry about nodes, servers, and how to provision them or configure them. All you need to do is create your tables, configure them as per your requirements, and let the service handle the rest. One of the most important things about DynamoDB is the fact that it is designed to deliver consistent and fast performance at pretty much any scale. If you model your data properly, then you can still expect the same performance in terms of latency and high throughput, regardless of whether you have a small table with a few thousand records or large table with millions of records. Now let's zoom in a little bit. In DynamoDB, data is stored in tables. And within a table, there are items. For example, if you see here, the first item has 5 attributes. Each item can have a different set of attributes than the other items. That goes with any NoSQL database. And just like any other database, there is a concept of a primary key that uniquely identifies each item. But the primary key itself can be further subdivided. First is the partition key, which is mandatory and it determines how the data is partitioned internally within DynamoDB. And then there is the sort key, which is optional, but if you specify it, you will have a composite primary key. And as you might expect, sort keys are useful for range queries, and they are also used to model one-to-many relationships. Go support for DynamoDB is available via the DynamoDB Go client. But just to be clear that this client is part of the larger AWS SDK for Go, which also supports lots of other AWS services. Currently, V2 is the latest version for the AWS Go SDK. Now, when you are starting out with the DynamoDB Go client, it makes a lot of sense to understand its sub-packages. So there are two top-level packages, service and feature, and both these packages have separate Go modules for DynamoDB and DynamoDB streams. The service DynamoDB module consists of the core Go types, and the feature DynamoDB module consists of specific components such as support for DynamoDB expressions. I have provided links to the respective modules for you to dive in. Now, one thing I really like about DynamoDB is its simplicity. In spite of being a large-scale distributed system, the primitives that it exposes are relatively easy to understand. So in this slide, I have listed the APIs which DynamoDB provides and categorize them by operation. For example, to create or save data in DynamoDB, you can either use the put item or the batch write item APIs. In the previous demo, I implemented two Lambda functions. Let's complete the functionality by implementing the rest of our application and the specific part that interacts with DynamoDB to save and access data. Now let's write the persistence logic that's specific to DynamoDB. We start by creating a new directory and create a db.o file inside it. Okay, we start by writing the imports as always. And then we declare variables and write the init function. In this init function, we get the DynamoDB table name from an environment variable and initialize the DynamoDB client object. Then we write the logic to save a URL to DynamoDB along with its corresponding shortcode. In this function, we first create a map of string to attribute value object and add the original URL, shortcode, and the status. Then we call the put item API to add this information to the table. Now let's write the function which extracts the original URL, provided a shortcode as an input. Now in this function, we invoke the get item API, specifying the shortcode as the criteria. Now this is a very fast operation since shortcode is the primary key of our table. So once we get the corresponding URL corresponding to the shortcode, it's then returned by this function. And this function also handles edge cases when the shortcode might be invalid or inactive. Now we can save this file and run go mod tidy to fetch the dependencies related to this function. All right, that's done. Now, if we check the file corresponding to our function, now you notice that this is not a problem anymore because we have already written this function now. You've built a Lambda function including the persistence layer. Now let's dive into how you would package and deploy it. Now before I talk about packaging and deployment, I want to clarify the concepts of runtimes in AWS Lambda. In simple words, Lambda uses runtimes to support multiple programming languages. Each major programming language release has a separate runtime with a unique runtime identifier such as Python 3.10 or Node.js 18.x. Similarly with Go, one of the supported runtimes is called Go 1.x. Since Go compiles to a native binary, we can also use a custom runtime, which is also called provided.al2. But please note that the Go 1.x runtime is about to be deprecated soon, December 31st, 2023 to be precise. So it's recommended to use the provided.al2 runtime. The example I have here is for the provided.al2 runtime. In order to build a zip-based deployment, simply build your Go Lambda function just like you would for any other Go program. Zip the binary file and deploy it. What you see here is the AWS CLI option, but I will discuss a few others as well. To build a container image, you will need to use a Docker file. And you have a few options here. So you can use the provided.al2 base image or any other custom image. For example, you see the Alpine based image here being used as the custom image. Notice the multi-stage Docker file that has been used. This separates the build process from the final deployment image. So the final image only contains the files needed to run your application. Now, once you have the Docker file, you can follow the usual steps like you would with any other application. Build the Docker image, push it to a Docker registry. In this case, it's Amazon Elastic Container Registry or ECR, and reference the image during deployment. You have lots of choices when it comes to deploying your Lambda function, whether in Go or any other programming language. You can obviously deploy it using the AWS console or the CLI, but there's also Serverless Application Model, also known as SAM, and a host of other infrastructure as code options, including AWS CloudFormation and AWS CDK. So let me give you an overview of AWS CDK before I move into a demo. AWS CDK is pretty interesting because it allows you to define AWS services using code. It supports multiple programming languages including Java, Python, TypeScript, and of course Go. Rather than infrastructure as code, you can almost think of it as infrastructure is code. This means that you can reap all the benefits of programming languages, apply best practices, and leverage all your existing expertise. Now, in this example, you can see how I've defined a DynamoDB table using AWS CDK. Instead of writing AWS CloudFormation templates to define your infrastructure components, you simply write code and deploy them using the CDK CLI, which internally takes care of the heavy lifting of converting code into CloudFormation template and using it to create AWS resources. Like I mentioned, AWS CDK supports Go, and as you might expect, there is good documentation as well as API reference that points to the Go doc for respective service modules. For example, in this case, you see the DynamoDB CDK module. All right, as always, let's see this in action. So let's start by creating an empty directory and then we change to it. And we then bootstrap a CDK Go application. Now we have a project created for us. We can delete the CDK test Go file because we don't need it for this demo. And then let's go ahead and update the CDK.go file here. Let's first delete the contents and then start by adding our imports. So note that we are using some of the alpha versions of the respective services like AWS Lambda. These are experimental, but they provide a much simplified developer experience. So let's continue and declare some of the constants that we're going to need. And now we start writing the function to represent the individual infrastructure components. So first, let's take care of the DynamoDB table. And then we declare the shortcode function. This is the create shortcode function. And then let's declare the access URL function. Then we go ahead and create the API gateway HTTP API and add the create shortcode function as a route via an integration. We do the same for the access URL function. And then we specify the API gateway endpoint and the DynamoDB table name as CloudFormation stack outputs because we're going to use them in the subsequent steps. So that marks the end of our function, and finally we declare the main function as well. Now let's update the go.mod file to specify the dependencies. And then run go.mod'23 to fetch those dependencies. All right, that's done. Now let's deploy the entire stack. You can safely ignore some of the warnings for now. And then go ahead and create these resources. All right, now the stack is deployed. Now let me use the API gateway endpoint and export that first. And I'm now going to invoke the HTTP endpoint of our URL shortener application. Now I posted this URL to the application and got a shortcode corresponding to it. I'm going to go ahead and post another URL. And as you can see, I've got a shortcode corresponding to the second URL as well. Now we can check the DynamoDB table to confirm whether these have indeed been saved. So I'll copy the name of the table and use the CLI to check the contents. So as you can see, you can verify the table entries as well. Now note that I've used the scan command for this demo, but it's not fit for production usage or for very large tables. Now let's access the URL via shortcode. I'm going to use curl for this, and I'll enter the shortcode here, one of the shortcodes. So as you can see, the response which I got was a redirection to the original URL, since API gateway returned HTTP 302 with that original URL in the location header. Now I want to wrap up with some common patterns and best practices. Try to offload heavy lifting from your handler function, especially if you need to create and initialize objects like SDK clients that can be potentially reused across multiple Lambda invocations. This will provide performance benefits by reducing cold starts. One way you can do that is by using global state. In this example, notice how I've used the init function to declare the DynamoDB client object. Now, the Go programming language has always had rich support for building REST APIs. This includes an excellent standard library along with many popular packages such as Gorilla Mux, Gin, Echo, Fiber, Negroni, etc. But what if you wanted to run existing Go REST APIs as AWS Lambda functions? Now that's where the AWS Lambda Go API proxy can help. The AWS Lambda Go API proxy package makes it easy to run Go APIs written using frameworks such as Gin with AWS Lambda and Amazon API Gateway by providing adapter implementation for these frameworks. So you don't need to split your existing code into multiple Lambda functions and refactor them to work with AWS Lambda Go runtime APIs. Now, right sizing your function. This is applicable to any Lambda function and not just the ones written in Go. You can try and change your code to optimize the performance and cost of your function. But what if your code is not the problem? And you could find the optimal configuration that will allow you to run your functions at lowest cost without having to compromise on the performance. But this can take a lot of time and effort. And this is where Lambda power tuning can help. This is a free open source tool that you can get from GitHub. You can configure the tool with which memory allocations you want to test. The tool will then run your function multiple times under different memory configurations and will build a visual representation of the impact on performance and cost, just like you see here in this example. You can also use event filtering to configure a Lambda function to be invoked only when an incoming event matches a particular pattern. Irrelevant events that don't match the pattern will be automatically dropped, so you don't need to pay for processing them. This means less invocations while also reducing the need to add custom filtering logic within your Lambda function code. To visualize this, let's see the diagram on the left. Each message triggers a Lambda invocation, and some of the messages are processed and the others are deemed irrelevant by the function code and are discarded with event filters. So you can discard those events earlier in the chain so they will never trigger Lambda invocations in the first place. Alright, that's all I have for you today. To dive in deeper, I would recommend exploring these resources along with the content that I've linked to in the previous slides, including blog posts, API references, etc. So thank you for listening to this talk. I hope you found this useful. Please don't hesitate to connect with me and reach out if you have questions. Enjoy the rest of the conference.
Yeah, thank you very much for this nice content, Abhishek. Well, lots of code, Lambda, servers, serverless, and everything, and I'm sure it's a really beneficial talk. Thank you very much. And now here we are expecting, and I see him on our backstage actually, Valentin Deleplace. I hope I pronounce name and surname well, and I invite you here. Hey, Valentin, how are you? I'm not sure if I. Yeah.
Can you hear me now?
Yeah, absolutely. Hey, man, how are you?
Thrilled to be here with you and you all attendees. Hey.
Hey, thank you for joining us and represent Google Cloud here. I'm sure you guys know lots of stuff and have nice views of perspective what happens now, and you can share something interesting with us. Okay, what's on your side? How do you feel? Like, what do you got?
Well, I'm pretty excited to be presenting today about PGO, Profile Guided Optimization, which is a quite niche topic, very interesting. And as Alan Key would put it, I call it pop culture. Like, oh, compiler can do things. Let's learn about them.
All right, thank you. Let's see what you have prepared to us, and let's go there.
Oh. Hello everyone, my name is Valentin Deleplace. I'm a developer advocate at Google Cloud, and I've been a Go developer for over 10 years now. You can find me in the social networks Mastodon and X-Twitter. I love talking about Go and about cloud, serverless, software performance, frugal computing, user experience, and QR codes, because I love QR codes. My two most interesting public projects are programmingidioms.org, a popular website, and CoolMaze, a file-sharing mobile app. Their backend is written in Go, of course, and is hosted on Google Cloud. Today I'll talk about profile-guided optimization, which is an insanely cool way to optimize software performance. I will try to explain how. But first, I want to highlight some of the coolest features of the Go standard toolchain. Tooling is a long detour, but it's really important to put PGO in context. Let's go. Of course, we can run unit tests and integration tests out of the box with the Go command go test. Okay, my tests are passing. That's a relief. We have test coverage, which is the percentage of your lines of code that have been visited, that is executed by your automated tests. Here we can see I'm reaching 62%, which means I can do better by writing more tests to cover more possible cases in order to maximize the total coverage. No need to reach 100% though, in my opinion. It's not necessary and it would be deceptive, as you can have all of your tests passing and 100% of coverage and still have plenty of bugs that show up in production. A large test coverage is mostly a nice to have, but not a guarantee of any kind. The test coverage is a nice tool for human developers who use it as guidance to write extensive tests. But as we will see in a few minutes, it is also extremely useful to power some other instrumentation technology. We have a built-in benchmarking feature, which lets us measure execution times in order to optimize them when possible. For example, here we can see that function B is much faster than function A. The two functions have been executed thousands of times each, and it turns out that function A took 73 microseconds on average, while function B took 31 microseconds on average. So if you've written B as a replacement candidate for A, and you've ensured with extensive tests that A and B are indeed equivalent, they are doing the same thing, you can now decide to replace all of the calls to A with calls to B, because B is faster. We have a fantastic built-in data race detector that is used to discover concurrency bugs where synchronization is incorrect. These bugs are sometimes waiting the worst possible moment in production to occur and are notoriously difficult to diagnose, to reproduce, to debug, and to fix. Here the race detector has detected that a variable has been read and written to in a concurrent and anarchic way by two different Go routines without properly using a synchronization device like a mutex or a channel or a wait group. As the race detector is a nice guy, it displays the two guilty lines of code where the bug happened, so we can go and fix it. This tool was written some 10 years ago by Dmitry Vyukov, whom I want to heartfully thank as it's one of the most amazing tools in the world. No kidding. With Go, it is easier to write concurrent code, and with the data race detector, it's easier to spot tricky, elusive synchronization bugs. Just a note to highlight that the race detector does its thing at execution time, when you're running your program or your test or your benchmarks. There's no static analysis involved in the race detection phase, which makes it different from how, for example, Rust approaches concurrency safety at compile time. In Go, the race detector is currently the best tool we have for this. We also have built-in CPU profiling by sampling, which records at regular intervals at runtime the call stacks of the currently executing Go routines, and then provides infographics that show the functions that burn the most CPU time in a graph where we clearly see who was called by whom. This is extremely useful. It's called pprof, and if you have never tried it yet, I highly recommend it. I will show it live in a few minutes in the PGO demo. Now the flame graphs are based on the very same profiling data and are a slightly different graphical representation of it, very nice and interactive. We can click on a specific function to zoom in and inspect where the CPU time is spent. We have built-in tracing, which is all about recording all the function calls dynamically in order to visualize if each of our CPU cores is spending its time working or whether if it's mostly idle. The timeline is interactive too. That's very neat. You can zoom on a specific millisecond and click on a rectangle to discover which function was executing on this processor at this millisecond, etc. Very nice and very useful. For 2 years now, we've also been having built-in fuzzing. Fuzzing is a powerful testing feature that lets you bombard your software with millions of unexpected or corrupt inputs in order to discover crashes or incorrect behavior. We fuzz a program during the testing phase for security reasons before deploying to production, because the internet is full of bad actors who would be delighted to find our security flaws before we do. Here, the fuzzer has caused a bug in the function A after trying for 4 seconds only. This is similar to the output of a regular failed unit test, except the test was executed on millions of weird inputs that a developer would not be expected to write by hand. Thanks to fuzzing, we can now fix this bug before any bad actor tries to take advantage of it. And now we have also built-in PGO in preview. But before I explain PGO, I want to emphasize that all of these instrumentation tools are integrated in the standard Go distribution. This is extremely important from the structural and sociological point of view to have this common framework, this tooling collection that will be supported in the long term by the Go project. You can be confident that they will still be working in 1 year, in 2 years, in 3 years. This shouldn't prevent us from using third-party tooling like Testify, Datadog, etc. But there's a huge added value in the long term to have a rich standard tooling, properly integrated and supported. That is, tools that play nicely with each other and also with the future versions of the language. So, what is PGO about? A traditional compiler takes your source code as input and passes it through various analysis phases and synthesis phases to finally produce an executable file. We can view the compiler as a single black box that takes one input and producing one output. However, this is not complete because we can also pass compilation flags intended to fine-tune the behavior of the compiler and to make more aggressive or less aggressive optimizations. We can say that all of the information used by the compiler to do its job lives in 3 places. First, in the source code repository, including all of the dependencies. Second, in the rules and heuristics encoded in the compiler itself. For example, should I inline this short function or not? Inlining consists of replacing a function call by the full body of the function at call site. The logic to take this decision is encoded inside the compiler. And third, in the compiler flags that can override the compiler defaults. All of this information is static. It does not take into account what actually happens at runtime at all during program execution, because compilation comes before execution. This is called ahead-of-time compilation. Things are different with interpreted languages. The virtual machines like Hotspot for Java or V8 for JavaScript are able to continuously analyze the code being executed. Just-in-time compilation allows adaptive optimization, such as dynamic recompilation. This is good news for developers in interpreted languages. PGO for Profile Guided Optimization, also known as FDO, Feedback Directed Optimization, it comes for free in the sense that it's the job of the VM vendor to make the magic happen. Developers are just either happy to know these optimizations automatically happen, or equally happy to have never heard about them, and they still apply. For statically compiled languages like Go, however, there is still some hope. you can compile your program, run it in production for some time with profiling enabled. As we've already seen, profiling is about recording runtime events, like the number of times the function was called and how long it took. So this data is saved into a file, and this profile can then be used as an input next time you compile your program. It is telling the compiler, here is everything I know about the program execution. Now you can make more informed decisions and produce better optimizations. The profiling data will help the compiler with decision making in a probabilistic manner. It contains information about which cases actually happen often or not. The semantics of the generated machine code is still exactly the same, but it is now optimized to prioritize the most frequent scenarios. Now CI/CD. Introducing PGO in a compilation pipeline requires to take time into account. We need to compile the project at least once without any profiling data, and then execute it for some time in order to gather a meaningful profile, and then compile again. This sort of feedback cycle makes CI/CD look a bit different than usual. When collecting profiles, it is important to make sure you're recording enough information to compare the performance before and after PGO. If you want to measure, you do want to measure if PGO had a negative impact or no impact at all, or a positive impact, and by how much. It is very tempting to automate the profile collection phase by running a load test or a benchmark, and then recompile with PGO before releasing to production. This is technically possible, but please be aware that benchmarks are not the real world. For this workflow to produce any meaningful results, you need to design a load test that very closely mimics your production traffic. PGO was introduced this year, 2023, in the standard toolchain of the Go language. The promise is quite modest. If PGO works well, your project may gain between 2% and 4% CPU usage improvement. I will now enable it explicitly in a real project and find out if we get any speedup. So I have a Go file that contains some business logic. It's all about opening a text file, reading the bytes, parsing them as strings and integers into a Go data structure that is called message. So the message type definition is here, an int, a string, some slices. Okay. So let's see. Parse adect messages would be the function under test or under benchmark. And we have a test file. This test file, adexttest.go, does not contain any unit file, unit test, but it does contain a benchmark. So the benchmark mostly consists of one loop that in the loop is calling the function parse messages. And parse messages is calling the function parse adx messages in a loop inside a Go routine with many Go routines. So it's benchmarking the concurrent execution of this function, because this is usually more performant, especially if you have a multiple core machine to do the work concurrently. Okay, so if I'm running the unit test, it will tell me you have no test to run. We don't have any unit test, but we do have a benchmark. So go test -bench equals dot. It will take some time, maybe just 1 or 2 seconds, and it says that this benchmark has executed the function 66 times, and the execution of the function took on average 16.4 million nanoseconds, that is 16.4 milliseconds. Okay, cool. And the function being parse messages. If I run this benchmark several times, I would expect some variance in the results, because in benchmarking in general, there is always some variance, some variability that can be quite high if you're benchmarking with your laptop, with Chrome or open in the background, or if you're benchmarking in a very small VM in the cloud that is mutualized and shared with many other tenants. So from one run to another, you could expect the numbers to change quite a lot. But here it's pretty stable. It looks like our function is always taking 16.4 or 16.5 milliseconds. And now PGO. First, I need to run the same code, but I'm not interested in the results. I'm interested in creating and gathering a CPU profile that I will call a.prof. Okay. This was very short, so I did produce a file a.prof that contains how much? 12 kilobytes of data, but that was over a very short duration. So that might be more relevant and might improve the performance if I gather a larger profile. So let's do the same, but bench time equals, let's say, 6 seconds. That should be longer. Yes, I think I did not make a typo. And so I should have more than 12 kilobytes of profile after that. Yes, I now have 35 kilobytes of profile. That's slightly better. So now I will measure if I use this information to run the same benchmark, will the performance improve or not? Let's see. So now we'll use the brand new flag PGO equals the name of my profile file, a.prof, and see how long it takes. Suspense. Okay, it's still 16 point something milliseconds. Okay, so let's play best out of 5. So if I remove the profiling information, that's the numbers I will get, means before PGO, and I run it 5 times. And I take the best out of the 5. And as we've seen, it's pretty stable. Okay, so without any PGO, the best it can do is 16.4. Now, with PGO enabled, best out of 5, let's see. Oh, that's slightly better. It's still 16 milliseconds, but maybe out of 5, we will have some improvement. Yes, 16. Okay. So what we can see here is that the best numbers with PGO enabled are 15.9 divided by the best out of 5 here, 16.4. Okay. That would be almost 97%, which means that PGO has brought us today 3%. And of course, if you would like this to be statistically significant and more scientific, you should gather the profile over many minutes and then measure the improvement before and after over many minutes as well. And then you have something very strong, and there is also some tooling like bench stat, things like that can help you measure and pretty-print the improvement. So we've used a file a.prof here that does not need any visualization by PGO, because PGO is just software. But when humans are working on performance, of course they like to visualize the profile and sometimes discover opportunities or surprises. So here we can visualize it with go tool pprof. and open a local port, let's say 6060, and open the profile a.prof. Let's do that. Serving UI, yay, here it is. Okay, so what does it say? It says that the function that took the most time was parse ADEX messages, which was the function under stress, under test, which calls our package functions preprocess, process, map line, parse process token. All of those are defined in our own software, and our functions, of course, in the end, they are calling the functions from the Go runtime. So here you have map access, which means I am reading in a hash map. Yes, here map assign means I am writing in a hash map. And then you have malloc.gc that is called by mostly any line of code that is allocating anything on the heap. Maybe also on the stack, I'm not sure, I think only on the heap, but this is definitely related to memory allocation and garbage collection, which itself calls even lower level functions from the Go runtime. Okay, very cool. This is super valuable information. I mean, I'm a good developer, so I have intuitions about which ones of my functions are supposed to take time or not. And then I visualize the pprof graph and I discover that I was wrong because maybe some regular expression was much more expensive than I expected. Or maybe some very small function somewhere was much more expensive than expected. Just because it was allocating memory over and over every time it was called. And so this type of graph will help a lot in discovering bottlenecks and maybe in improving them. Sometimes it's about removing code that does nothing, so that's executed in vain. Sometimes it's about refactoring, so it's always very interesting, and sometimes it can save you some CPU time and some money. I talked earlier about Flame Graph, which is extremely nice, and also basically it's the same information as the graph, slightly different because here, for example, all of the functions that call runtime malloc.gc that will end up in the same box. If you represent this in a Flame Graph, you will have the calls to malloc.gc scattered in different flames. So it's more precise in a sense. And here you can see that most of the time spent in parse ADEP messages, it was spent in a function called process, which itself consists mostly on calling mapline. And that mapline spends most of its time calling parse complex token. So maybe I was or was not expecting parse complex token to be the bottleneck of my benchmark, but now I can investigate, yes, it is a bottleneck, and why? Why is it so expensive to write in a hash map? Why is it expensive to call bytes.sleep? Maybe because it's using some arguments that I don't need. Maybe I need to re-implement my own version of split that would be more frugal or whatnot. So Flame Graphs invented by Brendan Gregg are really nice and already integrated in the web UI of pprof. That is super nice. And today, as we've seen, we've gained 3% of efficiency in our program thanks to PGO. Now back to the slides. Forward compatibility. What is that about? Because of the multiple cycles of profiling and compiling, it is useful to make sure that profiles are not invalidated every time we change something in the codebase. The Go team has worked hard to make sure that previous profiles remain as relevant as possible when iterating. If you want to learn more about PGO in Go, there's a nice article on the official blog of the Go project at go.dev/blog/PGO preview. While some optimization opportunities are leveraged by the compiler when doing PGO, not all of them are already implemented. I mentioned inlining, one of the first optimizations already taken advantage of by PGO, which is nice because inlining in Go is usually very conservative, optimizing only some short functions whose number of instructions fit within a very tight budget. You can follow the process on GitHub, where a checklist issue has been opened by Austin Clements. The good news is that all of these boxes represent hard work for the Go team, not for you as a developer. PGO in Go is expected to improve over time. Is this knowledge actionable in your project? Well, for most developers, don't worry about PGO. This is pop culture. Just nice to know it exists. However, if you are a Go developer and your heavy workload is costing 1 million euros of CPU, then enabling PGO may save you 20,000 euros, which is nice. And now, a short word about the wonderful world of Google Cloud. We've recently launched the Google Cloud Innovators Program. So if you're a Google Cloud user, or just curious, or if you'd like to deploy Go applications in Google Cloud, please type this super short URL or scan this nice QR code. Thank you very much for listening, and see you soon in the Go community.
And thank you, Valentine. Can you hear me? Maybe the internet is lagging. Milliseconds comes to seconds, comes to minutes, and then they come to thousands of dollars. Yeah, you're probably watching us on the platform, not on the backstage. Yeah, so come back to the moderators and speakers place. You will see me in real time. Thank you for this talk. It is really beneficial for those who care about budgets. Thank you very much.
You're welcome.
What city? You're in France, probably, right?
I'm in Paris. I'm in the suburbs right now, but the office is inside Paris.
Oh, how do you like it? And probably the weather is better than in the UK now.
Well, there just was a lightning at my window, which means it's storm right now.
Oh, then we're lucky to have just a shower here. All right. Thank you for sharing this, I think, crucial stuff, how to save on our applications. And now I see, thank you. And now I see the next speaker on our background. I want to invite here but now I see some messages from our technical team. Yeah, just to remind you, Valentine, in 30 minutes, we're going to have a Q&A session, and it usually really is something interesting. So, yeah.
Awesome.
Thank you very much. See you there.
See you. Who's our next speaker? Is it Nir?
Yes, and I am inviting Nir and some other guys there.
So excited.
Hey, bro. Yeah. And you guys probably know each other, right?
No.
Not yet. So that's a great
yet.
opportunity to connect in social media, right? And we are Commodore, right? That's what it says on your back. Yeah, and we're Geekle here. How are you, man? Where are you now?
I'm great. Now I'm in Tel Aviv in my office at Commodore. Next to me there is you don't see him, but is Udi, is one of our dev advocate in Commodore, Devo, sorry. And that's my position right now.
All right. And you prepared something about loops closing, loops closure, and everything. What is that? Why
Lot
it's
of
so
for loops,
important?
a lot of
Tell me more.
closures.
Yeah.
Yeah. So
Why it's important? Yeah.
yeah, so the for loop enclosure, generally for loops in Go in any other language are very important stuff. It's one of the most basic concepts in any programming language, and in Go there is some knowledge gap regarding those for loops and how they behave. And in the last year, there was a very interesting discussion regarding the behavior of the for loops. It's now there is an experiment that will get in the next version of Go in version 1.21. And in that experiment, they're going to change the behavior of the for loops. And if the experiments go well, after the next versions in 1.22 or 1.23, this change will be the default behavior of the for loops in Go. And in my presentation, I will present why people wanted this change, why it was like that before, what is the effect of us as Golang developers, and how it compares to other programming languages.
Cool. Thank you very much. I feel like we'll have lots of questions on that. Even I didn't hear your talk, but I feel like that. Before we start, I would love to mention that in 1 week we at Geekle are going to have the huge JavaScript conference, and 2 days, lots of GraphQL, lots of Node, React, Angular, and everything. PVA is something like which is like talked to the most and everything. So yeah, we invite you. Like as I mentioned on the beginning, super cheap tickets, never cheaper before. Just go and check. After the Nierstein will present us about. Closing the loop on for loop closure. Let's go there and check it out. Yeah, by the way, sorry, we had this like free part of 2 tracks and it's over. And if you are watching us on YouTube, please jump to our platform and of course continue to enjoy this content. All right.